Okay, so what we're going to talk about today is we're going to talk about machine learning for text, okay? Not for numbers, because numbers are for clever people, and I'm not a clever people, okay? So we're going to do numbers for text because I can speak, okay? I can speak in 2 languages. That's English and bad language. I can curse. I'm very naughty, okay? So we're going to talk about text using web data. So what is web data and why is it important for natural language processing, which is text machine learning? Web data is every place that we go on the web. It is on a news website. It is on an e-commerce shopping site. It tells us the list of our products, the description, the price, all these different things. We have it on a blog. We have it on Medium. We have it on Instagram. We have it on Twitter. And it's not just about text. It's also about the text and information that is inside other media. So you say, but like YouTube. YouTube it's not text. Well, if we can get the video and separate it from the audio and then transform the audio into text, it's text, okay? It's just speech. So this is all about what we can do with text on the web with machine learning. I'm going to ask you this question. Chicken is to puppy like toothpaste is to blank. Anybody, any ideas? Huh? Exactly. Okay. So this might seem like a very strange thing. A chicken is to a puppy like a toothpaste is to toothbrush. I'll explain to you a little bit later how we make this jump, okay? How can we show this relationship in text? I'm going to turn off this one here because it makes it echo. So first of all, let's get the elephant out of the room, or maybe bring the elephant into the room. Machine learning and AI, it's not scary, okay? It's not just for PhDs and really clever people and everything else, okay? So when they say, oh, the robots are going to come and take our job, they're not, okay? Don't worry about this. We are the ones who do this. Engineers are the ones who come up with this magic, okay? So this is the thing about AI versus machine learning. This guy did a tweet, and he says, what's the difference between machine learning and AI? And the answer is, if it is written in Python, it's machine learning. If it is written in PowerPoint, it's AI. In other words, when you hear somebody talking about, ooh, AI, guess what? They're a salesperson. Okay, AI is not rocket science. We're going to have a lot to go through, but you know what? My talk was delayed starting, so we're going to make it really long just to bore everybody, right? So AI is not rocket science, and I want to show you a small example. Does anybody know what this is? What is it? Okay, you can all leave. You're too clever, okay? You don't need to be here. This is an algorithm in a very strange outer space, crazy-looking language, okay, that none of us understand except the smart guys and girls over here, okay? But actually, this is what it means. It's about anomaly detection, right? It says, find the average of something, then find the difference between each data value, then take the absolute value of the difference, and then find the average of those differences. Now, if I said to you as an engineer, go and implement this, okay? I would say, well, I mean, I know the clever people are over here, okay? But the rest of us who are stupid over here, right? The rest of us, including me, we would start crying, oh my God, I don't know what to do, okay? Because this looks hard, okay? This looks hard. But if I said to you, here is a simple project specification. You have 1, find the mean. Oh, okay, total up and divide by the number of, yeah? Then find the difference between each of the values. Well, just do a little array, that's easy, okay? So the message I want to get you across is that this stuff is not difficult, okay? You don't need to be afraid of it. You should embrace it, okay? What is an expert? An expert is somebody who knows one sentence more than you do. If I say something that you don't know, you go, oh my God, he's an expert, okay? So if I want to come up here and do a conference session, all I have to do is keep a blog over here that one of the clever people over here have written, and then I just read this blog, come over here, I say one sentence from this blog, and then I say, please wait 1 minute, I need to go for chai. I come over here, I read my blog again, I come back over here, I read the second sentence, and I seem like an expert, okay? Everybody can be an expert. Don't worry, dig in deep. Okay, so this is the context of what we're going to talk about. The agenda of what we're going to run through now. We're going to talk about web data, and I want you to be very careful with this word data. We're then going to talk about information extraction, which is really different from data. We're going to look at some simple use cases that you can bring back to your workplace, and you can implement these, and you can look like an expert, okay? And then I will show you some tools and some resources to get you started. So, my company, we do web data harvesting, we do scraping, lots and lots of scraping, okay? And my talk yesterday was about big data, and this was some of the lessons we've learned doing that there. And this is the same with machine learning. People think, oh, this type of stuff looks like this, but actually, this is what it really looks like, okay? And this is the same with machine learning and with text and machine learning. There's many, many, many different things that you do to get one outcome. This is not Harry Potter. It's not one piece of magic does everything. It is a number of different things put together, okay? It's all APIs. So here is one example. We know that we can take an image and we can examine the image with some simple OCR and we can extract the text. Yeah, everybody agreed? Okay, like we could do this before. I would say if I took the average age of everybody here, okay, I would say that we could do this before you were born, okay? This is old school. This is easy, right? So the next thing then is we can say, okay, in an example, there is an image, right, of this beautiful giraffe, and we can do some OCR, and we can take out all of these words. So now we have text from a binary media image. The next thing we have here is we have a thing that comes from Azure Form Recognizer, okay? And I want you to keep this one in your head because this is going to be like a magic tool for you in future, okay? It is absolutely, most of the things that we do with machine learning for text is we try and take data and information out of forms, out of blocks of text, out of pictures, right? And Form Recognizer allows us to hook into an API and get this information really easily, okay? So in this case here, we have an invoice, right? And we want to extract this information over here. And what it can do is it can not only take something that is nice and easy like a structure, but it can take a photograph like this, okay, of a receipt. And in this here, not only is it taking the information, oh, my battery's running low. We don't want this. And I am plugged in. Am I back on? Is this not working? Okay. Okay, we will leave that to Simon to do. So the interesting thing is that not only did it figure out the text block information from here, but look, it also took out the handwriting. Okay, so that's really interesting. It could take out the handwriting and transfer it to clean data in the same way as the other. Did we get power?
I think
Is it showing green? Yeah. Okay, well then we're good. Everybody give Simon a round of applause. Huh? Okay, very good. Okay. So, another one I want you to look at is that this contoso up there, the logo, right? It's curved, okay? It's almost like, does it remind anybody of anything? It's a bit like a CAPTCHA, okay? Okay? So this type of thing, also very easy to do, right? And this one here, what it does is, in Form Recognizer, it recognizes that this here, look, you can barely read this, but it's taking the twisted words and it's untwisting them to make it into a proper address, and then it recognizes that these are different line items on the receipt, and it's putting these out into separate line items here. You see this? Okay? You do not have to go off and learn the very obscure mathematics behind how this works. Guess what, guys? You just call an API, okay? So it's that easy, right? So you need to go and look at Form Recognizer. So now, the next message is that data extraction is not information. They are two different things. Data and information are not the same. So if we look over here, we can say data is Intel 7th generation i9. That's just data, okay? We don't know anything about that. But when we extract this, we can say the brand is Intel and the processor is the i9, okay? Or we might say the family is the i9 and the version is 7th generation. Does that make sense? Okay, so information versus data. Same thing, here's something that's not like a product, but maybe it's more speech orientated. Martha travels on the bus to school. The person is Martha. The transport is bus. And the destination is school. Okay? So again, seems like it's getting a little bit harder, but I'm going to show you how we do this. This is a thing that we call multimodal analysis. And you can forget about the modal. It just means mode, which means type. So multi-type analysis. This is where we're looking at some data from the web, and it contains information about the product in text here. It contains a picture of the product over here. So what can we tell by looking at this using various means? Well, we can get the breadcrumb, easy for scraping, the name, everything else, easy from scraping, right? But how about in the image, okay? We can look at the image and we can say, oh, that's a category t-shirt. It is a black color, right? It's got short sleeve, and on the text, because we extract the text, remember, it says Hellfire Club, okay? So there's a lot of things that we can do with simple APIs to get this. I'm going to skip over this one and go to the next one. Okay, so all that's wonderful, and who cares, okay? What are some of the interesting use cases for NLP? NLP stands for Natural Language Processing. Okay, so sentiment analysis. We know this one, okay? Is Alan happy? Yes! Is Alan neutral? Is Alan sad? Okay, so we can see these things easily, right? And that has been around for many years. The next thing we can do is we can look and we can do maybe things for data quality. So I look at, I like puppies. Who likes puppies? Oh, yes, yeah. So up here, we have this product about the puppy, but something is wrong, okay? It says Baker's puppy dog food, but something's wrong. Anybody know what's wrong? Huh? Okay, yeah, so there's different things we can see here, right? The guys were right. They said it says 1.1 kg, but the image over here says 12.5. So we can extract this from text, and we can do a data quality with the text, okay? Anything else? Okay, kg. Anything else? How about this? Puppy dog. Adult. Okay, right? That's the main one, right? So it says puppy dog, and actually it turns out that this is an old guy. He's still cute. I would still go, oh, you're so cute. Okay. But this guy is, ooh, 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 right? I really want this guy, okay? So you can see that not only in data quality were we able to just use the text, nothing but the text, right? And say, this looks like the wrong image, but then when we put the correct image in, suddenly, why is this interesting? It's interesting because if you go to an e-commerce page to buy a product, and it says one thing, but the image shows something different, are you likely to press buy on that product? No, no, sir, no, no. Because you're not sure if you can trust this or not, okay? So this goes back to actually even a question that we had yesterday on a panel, which is, you know, what is the most important thing that we should do when we're talking about code, and it's code quality. Because this type of thing, code quality, data quality, UI quality, everything goes back to making the user happy and comfortable, okay? So now we're getting into something really interesting. This is review analysis. So it's very common for people to say, oh, this has 5-star review and there was 20 different people or 100 people left a 5-star review. That's easy, right? Okay? So how about this here? We look at translation and we say, oh, we can translate from one language into another language. Okay? And you say, oh, that's kind of cool. But it's also really old, right? It's been around for a long time. Now it's getting better, but it's been around for a long time, right? So what are we doing here that's different with text and machine learning analysis? What we're doing is we're saying sentiment. So if we go through the review and we look for bits of information, we can find really interesting insight. This one says to us the product is good, which is sentiment. And this one says we have a problem with service, okay? And this is actually a huge area of research right now, and it's called aspect analysis. And companies are looking for people to go and write solutions like this that will help them understand where their products are going wrong, okay? Because if someone goes in, like the example I said of you went to buy puppy food, but there was sent out to you dog food, and then in the review I go, 1 star, I ordered puppy food, they sent me dog food. I was so sad. My puppy has not eaten, my puppy has died. Like seriously, okay? So companies now are paying people to go out and to write solutions like this because they can learn from the reviews what is going wrong with their product. Does this make sense? Okay, good. So review mining research, and I will tweet this out later on, okay? So mining product innovation ideas from reviews. Wow, that's really interesting. So what we're doing is we're just using this very basic text analysis, okay, to say, is somebody's review positive or negative? And then we're saying, take out the parts of that review and see what can we learn from that. So if somebody said, this is a great product, but I wish they offered it in red because that's my favorite color. Innovation. Need to make the product in red, we'll sell more product, okay? If someone said, this is a great product, I've sent it back because it didn't fit in the airline baggage compartment, okay? Oh, product innovation. Make it 1 inch smaller so that it fits into the cabin baggage, okay? So they're using it for this type of thing. Another one is defect discovery, right? I bought this and I sent it back because the package was broken. Oh, so we need to use stronger packaging, okay? It's just text analysis, okay? It's not difficult. These are the use cases. I'm going to zoom through some of these ones here and move on. Okay, so another thing we can do with text analysis is we can look at attribute or taxonomy standardization. Why is this important? Because we know that when we go and collect data for a customer, they usually have their own way that they want to store this data, right? Everybody has their own way to store data. Everybody has their own schema, their own database structure, okay? However, when you go and collect data from the web or even from a document or a PDF, it's in a different structure. So how can you bring it into the one structure? How can you standardize this? And we can do this again using natural language processing. So here is an example of, I know, I'm sorry, it's too small, but here's an example of 3 product listings from 3 different websites, and it's about this thing here, right? And it basically says, you know, the size, the dimension, the resolution, the power, whether it's got Android TV, all this stuff, okay? So all that information is in there on these different sites. But if you look here, it's interesting because this site has actually less information, this one has a little bit more, and this one has a little bit more, okay? So how do we pull all these together, right? So in this here, we send a bit of ML, woo, look at that robot go, okay? That's a little robot guy. So what we do is we take the information in and we put it into, if you like, columns like this. And then we can say, for each attribute, okay, what did the particular data source say? So this guy over here says the display resolution was 1366 by 768. This guy said HD ready, 768. This guy said 768. So are they all the same? Yes, they are, okay? So which one has the most information? The one in the middle, okay? So will we use this one? Well, the answer is it depends. Because if the sample data that the customer gave you says that they want the most information they can in the field, well, then that's the one that you use. But otherwise, you use the one that matches theirs, okay? So the way that it's done is, how can this stuff be done, right? I've talked about, these are different ways of doing things and everything else, right? But how do we actually do it? How do we manipulate language, okay? Because now suddenly you're looking at this and you go, hold on, he told me we didn't need to be clever, okay? We didn't need to know math, okay? We could like be with all the city folk over here, right? So how do we do this? Well, here we go. This is called ambiguity, okay? And what we need to do in text analysis is we disambiguate. We take away the ambiguity, okay? And in this case, we can see 1080, 1920, the only difference there is P. This one here is screen size, this one here is resolution. They're meaning the same thing, okay? This one here is reversed. Look, instead of 1080 by 1920, it's 1910 by 1080. This one here has an X in the middle, this one has a space on either side, okay? So we look at these things here. And this is where it all comes down to, right? We use different techniques, I'm going to tell you how to do these, right? To say, if we start out with this one thing, one line, okay, of product description, what we do is we break apart the different constituent labels, remember this word labels, okay, inside, so we can extract from this, that is the size, that is the model, that is the product type, okay? How do we know that that is the size, and how do we know that that is the model, okay? Well, like, if I didn't show you this here, these words, if I said to you, what is the size, would you as a human be able to look at this and tell me the size? What size is this? 55, yeah? You see it? Okay, 55, okay, that's the size. We can read this with our minds very easily because we see a pattern. And that is what text analysis is all about. It's about patterns. So from that, we can break down different patterns and group things in different ways, okay? So now, tools and techniques. Extracting information, not data, is about relationships and about context. These are the two critical differences, right? It's not, sentiment analysis is Boolean. It is either happy or it is sad, okay? Or it's neutral maybe, but that's just the 0 point, okay? But when you're looking for information, two things, relationship and context. Okay, here's a cartoon. They went to the restaurant. They ate some pizza with anchovies. An anchovy is a small salty fish, okay? So number one, they ate pizza with fish. And we see this here, they ate a pizza that contained fish, okay? Now if you take this same word, this same sentence, okay, and think of it in a different way, which is dip, 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 this way, it looks like they're eating pizza with fish, using fish to take up the food. Do you see the difference? Okay, and they're kind of going, oh my God, how can we work this out, right? So, the way we do it is we break up the words into different grammatical parts. So we say, they ate pizza with anchovies. They is a proposition. Pizza is a noun, okay, place, person, thing, right? With is, okay, right, etc., right? So you can see how this works in the graph, okay? So, in here, we're breaking it down into two parts, and we can say they ate pizza with anchovies, okay? Now, this is what's called the universal part of speech tag set. And you said right there where you said preposition, there's only a certain type of tag we can put on every word. We can say something is an adjective, a noun, it is punctuation, it is a pronoun, etc., okay? Sounds like Dave is throwing a guitar picks. So when we look at this here, we can say, we can beat this. So when we look at this here, we can say, we will meet at 8 o'clock, right? Pronoun, auxiliary, verb, adjective, number, noun, punctuation, okay? So we can break it apart. Does that make sense? And then once we have it breaking apart, right? So we use this thing called named entity recognition. And named entity recognition says, take the parts of speech. Now this is important, okay? Focus, right? Take the parts of the speech and use them to extract meaning. Use them to extract information. So we know that WeWork looks like an organization. Adam Newman looks like a person. Manhattan is a location. 3.7 million is a monetary value. Does that make sense? Okay? So we use recognizing parts of speech is the key to getting information out. This is the same thing here in a bigger version, okay? Now, words as numbers. So, this is back to chicken is to puppy as toothbrush, exactly, right? So this is words as numbers, right? How likely is it that it is one thing or another thing? How close are we, right? So the way we do this is we ask a series of questions, okay? And we put them into a vector, which is just an array of numbers, okay? A vector is an array of numbers. And we say, series of questions. A cat. Is a cat a living being? Is a cat a living being, yes or no? Yeah, okay. So, is it more likely to be dead or alive? Alive, okay? Providing it's not, dead on the road. It's more likely to be alive. Is it feline, which means is it species cat? Well, yes, it's 0.9, it's very high. Is it human? No, okay. Now I know that some of you who have cats as pets would like to treat them as babies, okay? But they are not human, okay? Then, is it royalty? Is it king or queen? Okay? Well, some people who love cats would say yes, and they will treat them as royalty, okay? But they are not king or queen, etc., okay? So we just assign numbers to these different questions. And what we do then is we can take these numbers and we can do certain very basic math equations like do an average. Add these up and get the average, okay? And if we get the average of these things, well, then we can plot where they are on a graph. Does that make sense? Getting the average of the questions allows us to position them on a graph. And if we've asked the right questions, well, then we know that cat is going to be close to kitten. Cat is going to be at a certain distance from dog, but house is going to be way different from those there, okay? Why? Because of the numbers, okay? The numbers allow us to manipulate where something is in a hyperspace, okay? Now, the proximity is magic, okay? So remember I said about context and relationship? So this is where we can really use these numbers to help us. So we can say man is to woman as king is to queen. This is an old classic example, right? Man is to woman as king is to queen. Are we all happy that that makes sense? Yeah? Okay, now, here's some magic, right? Now I can use basic mathematics on language, okay? I can say man minus king equals, okay? So you see how it works? Okay, so this is how the relationship then works. Okay, it's the same numerical distance. And words as numbers, to expand it out, right? We can say male is to female. We can use it for a different question that we ask, a verb tense. Swimming, swim. Walking, walked, okay? It's different question. We can use it country to capital. Turkey, Ankara. Moscow, no, I'm not talking about those Russians, I hate them. Madrid, Spain. Berlin, Germany. Tokyo, Japan, okay, etc. So, this is how we can now say chicken is to puppy, like toothpaste is to toothbrush. Okay, makes sense? Cool, okay. So bringing it all together, and for our next speaker, we are nearly there, my apologies. Bringing it all together, right? We have to use all of the different tools and techniques to bring things together, right? So we looked at this text information from a website earlier on. We saw how we were recognizing the different parts of the speech in there, okay? And I want to know how can we pull that together. And this was bringing together my embedding, which is my vector math, with my entity recognition, okay, and putting it into a graph to be able to find out where the text sits. And those types of things are the basics of how we do natural language processing to extract information from data, because that actually is the most important part, okay? So now, the multimodal part that I said, using all of the different parts, these are the names that you need to remember, and if you want to know more about this area, you go and look into part of speech, vector embedding, word graphs, and proximity search. Source tools that you can use are these here, but forget about these. If you want to know more about this area, and if some of the things that I've talked about were interesting, exciting, or you just like puppies, okay? Well then, these are books that you should read. So you can take a picture of this one here, okay? So all cameras out and take a picture. The first one you should start with is maybe this one here, natural language processing with Python, okay? Then maybe the next one you could go to is maybe this one here, speech language processing. Then this one here is probably really good, hybrid. And then if you feel that you have a really big brain, okay, so these guys over here, okay? Now, like, if you leave your house in the morning, okay, so think of this. You leave your house in the morning and your mom shouts out, "Hey, you forgot your head wallet." I say, "What?" "You forgot your head wallet." So your head wallet, your head is so big, right, because you're so clever, you have to have this guy coming behind to hold your head, okay? He's your head wallet. So if you've got a really big head, you can read this one here, Artificial Intelligence Modern Approach, okay? This is like reading a really, really hard book. Remember those mad algorithm earlier on? This has lots of those, right? So this side here, don't read this, okay? Okay, so That is it. We, we probably don't have time for questions because we are under pressure for time for the next speaker, right? What I would encourage you to do is go to all the sessions. I will be around later on, and stop me and ask any questions you want. Is that okay? Because we've got to keep things moving now. So let's see if we can beat the guy. Oh, before I go, okay, I have some stuff here that I meant to give out. So, will you give them out? Okay. Who can tell me, let me see. What was the incorrect picture? What was the incorrect picture that was shown? Hold on. You get this here. You ready? Catch. Whoa! There we go. Pass this back. Okay.